morning to one and all. Myself, Ganesh Miriyala, and I am the assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. So, in last class, we have discussed about the operations on the signals, and those are few. And the operations on signals, we have studied about the first 6 one: amplitude scaling and amplitude shifting, addition and multiplication and differentiation. These 6 we already completed in the last class. Now we are going to be study the time shifting and the time scaling and the time reversal. So what is mean by time shifting? Time shifting means the original signal, whatever the original signal is there, so whether it is shifted by the left side or right sided. That means at a particular point, if you take at present time, we need to get the signal at this moment. So like if I take, this is the one point, at this point, this is our required time. I am taking it as a 0. This is, I am taking it as a present time. So this is about the present time on the time axis. If a signal reaches, this is a minus time. That means you can take it as a negative time. Negative, this is a positive. So let us take, I'll explain this thing with a small example, train. So take 0 as a present time, exact time and scheduled time. If a train reaches across this one, I am taking it as a x of t plus or minus 0. Let us take x of t plus or minus 0. If this t naught, you can take it as a x of t naught. X of t plus or minus t naught. If the t naught equals to 0, t naught equals to 0 means your signal will become it as a x of t only. That means you are at present exact. The time scheduled time it is, let us take it as a 10 a.m. The signal x of t, let us take it as an example, a train scheduled at 10 a.m. and it reaches at, this is a 10 a.m. Let us take it as a 10 a.m. Now the signal reaches, the train reaches at the 1 unit later. That means it is a at 1. 1 means 10 plus 1, it is a 11. It is a 11 a.m. Same at minus 1. So that means at this point 10 minus 1. That means it is equals to 9 a.m. So with this example, we can say this is a x of t minus 1 and this is a x of t plus 1. X of t minus 1, this one, and x of t plus 1, this one. Now how we are defining? So train must be reached at this point, but which is delayed by how many units? 1 unit. That means 1 hour. It came at the 1 hour. You can call it as a delayed signal. And actually the train should come across at 10, but it reaches at the 9 a.m. So this is the advanced signal. Sorry, advanced. You can call it as a advanced. This is a delayed. So for the left side, you can say it as a advanced signal. And for the right side, it is a delayed signal. This is a delayed signal. So similarly, let us define the time shifting. Suppose x of t is one signal and which is shifted by t naught units. If it is t naught, the t naught might be it in a negative direction or a positive direction, where t tends to t minus t naught. That means t naught units. Now your signal look like it is x of t minus t naught, where t tends to t plus t naught. This is a x of t plus t naught. So first one is, I already told you, it is a negative is there. So it is a delayed signal. And this one is advanced signal. So first one is delayed signal and second one is a advanced signal. So while you are drawing a graphical meaning, what do you mean by graphical meaning? Here it is. Graphical meaning of this signal, this operation actually. Graphical meaning, if it is delayed, that means how much units it is delayed? T naught units. That means you need to add T naught. Advanced signal, that means it is already advanced, we have additionally, so subtract subtract T naught. For the delayed signal, you need to add the T naught units, whatever the delay we are getting it is, we need to add it. And for the advanced signal, we are getting advanced means we need to subtract those T naught units, whatever it may be. This is in a graphical meaning. These are about the graphical meaning. So once we get across the example, then we will understand in better proper way. Look at this signal. This is one rectangular signal I have. Amplitude is, time is 0 and 5. Amplitude is, now I am taking it as a 9 units time t. This is x of t. I want to represent this signal like one shifted by units plus or minus. Let us take x of t plus or minus 5. I want to shift the signal. One is right side, one is left side. In this case, how we are going to be represented, and make a tabular format. You just write down the all possible time axis values. I am writing it as a time axis. Time axis, possible time axis is first 0, next one it is a 5, 0 and 5. So what are the corresponding amplitudes? Corresponding amplitudes, at 0 the amplitude is 9 and at 5 amplitude is 9. So there is no change in a amplitude. Now I am taking the first signal, it is x of t plus 5. X of t plus 5. T plus 5 means 5 units. So is it left shift or right shift? Since it is a plus is there, now it is a advanced signal. It is a left shift is there. So now it is left shift. So what is the T naught here? T naught is equals to 5. Left shift and T naught equals to 5. So what we supposed to do? For advanced signal, subtract T naught from the all time units. Value it is 5. T naught is 5 and here it is also 5. And what is the final time axis? Final time axis is 0 minus 5, it is minus 5, and 5 minus 5 it is a 0. So this is the final time axis values, but amplitude is not going to be changed at all. Now look at here, just check the time axis. What are the time axis we will have? Maximum 5. This value is minus 5 and it is the 0. Now this is the 0 location. We will have the 0 location. So you just look at here carefully. This is a minus 5 time and its corresponding amplitude is final one, top one. This is a 9. So I will take this point is a 9. And this is a 0 and its corresponding amplitude is 9. And again you will get this one. That means this is a signal. You just check this signal with this one and you will feel the difference. I am redrawing the signal like this is a 0 line. Now this 0 line. Now the signal is across the 5 and your signal look like this one. Amplitude is 9. Now this signal you can name it as a x of t plus 5. Right? X of t plus 5. So this is a signal. When compared to this one, your signal will be left shifted. The signal is left shifted by 5 units. So this is about the first one. So this is about the time shifting. Next one, time scaling. So time scaling means if you look at x of t is one signal and I am scaling where t tending to some ct. C tending to some ct. Now your x of t signal will become it as a x of ct. This is a time scaling. If c is greater than 1, if c is a greater than 1, your signal will be compressed one. Compressed signal. If c is less than 1, your signal expanded one. So what is the graphical meaning? Graphical meaning is whatever the signal you have at the time values, for time values you just divide by how much units? C units. Whatever the time values you will have, We just divide by the C units. Now look at here. I am taking the one signal 0, same rectangular function I am taking it as 0 to 5, 0 to 6 it is, let us take, and amplitude is 2, and this is a x of t signal. Now I want to draw the x of 2t. This is a first case, that means c is equals to 2. If I take c equals to 2, now same, draw the time axis values. First you can take time. What are the time axis we have? One is 0 and next one is a 6. 0 and 6. Next coming to the amplitudes. What are the amplitudes? At 0 you will have the amplitude is 2. At 6 also you will have the amplitude is 2. That means no change in the amplitude. Now for this one, what operation we are doing? That is a time scaling. By how many units? 2 units. Time scaling by 2 units. 2 units means, what is the graphical meaning? Graphical meaning, divide by C units. T units means 0 by 2 and 6 by 2, and its resultant is 0, 3. 0, 3. That means your final time values. These are the final time values. These are the final time values. Now draw the signal. So what are the maximum time values you have? 0 to 3. So this is a 6 value, 0. In between, this is a 3 signal. I mean at the 3 time constant, 3 time value it is 3. Now amplitude is same. At 0 amplitude, 0 time you will have the amplitude is 2. There is no change. If I take, this is a 2 line, line 2. Now at 0 I will have this point, and next at 3 you will have the amplitude is 2. That means this is a 2. So your signal will be, this one is 2, and your signal will be look like this one. Okay, when compared to this one, the signal width is from the 6 to, it is compressed to 3. So this is a compressed signal. That means C greater than 1. If I take one more, x of 0.5t, x of 0.5t. Next, from the same one, I am doing the another observation, time scaling with a 0.5. That means not for this one, this is already over. Now for the next one, on 0 divide by 0.5 and 6 divided by 0.5. That means this is a 0, resultant 0.5 means it is a value, it is 12. 0 and 12, these are the new timelines. So I am taking the another signal, amplitude is 2. Now this is 0, 6, this is a 12. So at 0, your time value and amplitude is 2, fixed one. Next I am taking it at 0 is this one. Next at 12, you will have the time value, it is amplitude is 2. That means around this one. So my signal looks like this. See, this is a C less than 1. That means 0.5 I have taken. This C greater than 1, I am taking it as a 2 value. For 0.5, the signal is expanded from the 6 to, this 6 to, you will expand it up to the 12. And for the C greater than 1, the amplitude, now the signal is compressed from the 6 to 3. So this is about the time scaling operation. This is about the time scaling, and we will take the another example also if you required. What we are doing? Okay, now enough. Next, take about the time reversal. Time reversal means if I take x of t is a one signal and my t tends to minus t now. Now your signal will be look like x of minus t. Your signal will be look like x of minus t, which is called the time reversal. And what is the graphical meaning? Is multiply with the minus 1. Multiply with the minus 1, so that then your signal will be obtained accordingly. So the same signal I am taking the one more one. This is one triangle function. So 0, this is 5 at t, and the signal is x of t. Now if I want to write the x of minus t, if I want to write, now take the same time amplitudes. What are the amplitudes we will have? First one, at 0 my amplitude is, let us take it as a 5. Amplitude is 5 and time axis. First of all you need to write the time axis 0, 5. At 0 we will have the amplitude is 5 and at 5 we will have the amplitude is 0. So this is about the general given signal. Now I want to do the operation. Which one? It is a time reversal. Time reversal means -1. You need to multiply with all by -1. 0 cross -1, 0, 5 cross -1. So the resultant is 0, -5. These are the new timelines and amplitudes are fixed, same. So for this one I am writing the time t across 0, 5. What are the required time intervals? We have -5 also, so that I am taking it as a -5 also. At 0 amplitudes, sorry, at 0 time you will have the amplitude is 5. At 0, you look at here. At 0, you will have the amplitude is, this point it is a 5. Now at -5 amplitude is 0. -5, this one. At -5 you will have the amplitude is 0. Then this is a 0. The first point is this one. Second point is this one. So we make a line like this. So this is about the x of -t line. This is a x of t line. So it is simply, it is a shifted version. I mean folded version. You can say it is a 180 degrees shifted version. So you can call it as a mirror image of x of t. This one. If you flip this signal with respect to the y-axis, then you will get the x of -t. This is about the time reversal. We have three basic these operations. One is time shift, next time scale, next time reversal. So if I have these three operations in a signal, if I need to do these three operations, which one I supposed to do first of all? So according to the natural order, you need to do first time shift. If you do the time shift, then you can do the next one, it is a time reversal or time scaling. It's not a big deal at all. But the first of all, you need to do the first priority is a time shift only. Once if you do the time shift, then you can do the next time reversal or time scale. So I'll explain with the one problem. For suppose this is a signal I am taking. Just take the same to get the normal 0 to 5. This is a 2 time interval t, x of t. I want to do these all operations on the signal, like x of minus, this means time reversal, 2 means time scaling, 2t plus 4 plus 4. This is the three operations. Minus is there, so this minus represents the time reversal, 2 represent the time scaling, and this 4 represent the time shift. So for this one, what we supposed to do? Just make the first of all table. You just make the table. It is, you will have the time interval. First write the time intervals, time values. What are the time values? I'll have 0 and 5. 0 and 5. Now what are the amplitudes? Amplitudes at 0, amplitude is 2, and 5 it is 2. This is also amplitudes are 2 and 2. Now according to the natural order, first of all we need to do time shift. So x of t, let us see how many units? X of t, where t tends to t, what will have it? Plus 4. T plus 4, that is x of t plus 4. First operation we are doing. X of t tends to t plus 4. First operation we are doing, it is x of t plus 4. Now the signal is shift operation. Which shift? It is plus is there. Now we are taking it as a left shift. Left shift means what we supposed to do? Left shift, it is a delayed version. We need to add plus 4. How many units? Left shift by 4 units. Left shift by 4 units plus 4. Plus 4 to the only time axis, not on the amplitudes. For the next one, what is the result? You will have the 0 plus 4, it is 4. 5 plus 4, it is 9. This is about the first one. So first signal is completed. I mean first operation is completed. Time shift is completed. So first we did it as a time shift. Next we can do the reversal or time scale. It's not a big deal at all. First of all, I am doing with the time scaling. So time scaling, with wherever t is there, you put the t tends to which signal you need to take? The next one. This is the input to the original signal. X of t plus 4, where t tends to, what is the value? 2t. T tends to 2t. So that means x of 2t plus 4. Which operation? This is a plus 4. Which operation we are doing? It is a time scaling. By how many units? Time scaling by 2 units. Once if you across the time scaling by 2 units, divide by 2. 9 divided by 2. So that you will get the, what is the result? This is the 2, this is 4.5. This is about the 2 and 4.5. Now this is about the divide by 2 units. Now it's the second operation. Next one will have the which operation? We'll have the time reversal. Take this as an input. So first one, this is the input over here. Now this is your input. It is x of 2t plus 4, where t tends to minus t. That means x of minus 2t plus 4. Since minus is there, you are already, then you need to multiply minus 1 with all time axis values. Multiply with the minus 1. So for this one, time reversal, you need to multiply with the minus 1. Multiply with the minus 1. So your result must be minus 2, next minus 4.5. Minus 2 and minus 4.5. These are the time values we will have. So in this case, we need to draw the signal. What are the time values you have? Minus 2.5. Sorry, minus 2. Next, this is a minus 4.5. So I will take this one. 0. This is a minus 2. This is a minus 2. This is a minus 4.5. Now your signal, check this one. At minus 2, what is the amplitude? Amplitude is 2. At minus 2, let us take this is a 2 line. So this is a 2. At a minus 4.5, your amplitude is 2. Your signal will be look like this. Okay. So this is a signal. We can name this signal as x of, this is minus 2t plus 4. This is a signal. This is about the operations on signal. So the only main thing you need to remember is time shift first. You have to do time shift first, then you can write it as a time reversal or time scale, or time scale or time reversal. But first one is you need to do the time shift. If you do this one, you will get the exact solution. So what we studied? First one, time shifting. Next, time scaling. Time reversal. So these are the 3 operations we have studied in this class. Then the next topic we will see the classification of the signals. Thank you.